Hey guys, I wanted to provide an additional video for you guys on chapter 12, which is still with statistics. It deals with z-scores, the empirical rule, which is still dealing with your standard deviation. There's lots of videos on how to find the standard deviation by hand. If you have a graphing calculator, you can use the graphing calculator to find standard deviation. And so if you have a graphing calculator, you can find the z-score on My Open Math. It kind of gives you some directions. But I wanted to go over how, if you don't have a graphing calculator, how to find the z-score. And honestly, using the chart that I've attached up here, it's just as easy as using the calculator. So let's take a look and share my screen, guys. And I'm going to pull up the whiteboard. All right, so real quick, the empirical rule just states that you have the standard deviation and your mean is your middle part. This is your mean. And if you have data values that fall within one standard deviation of the mean, this will be one standard deviation. And again, your book shows standard deviation with this symbol right here, okay? If it falls within that, that means that 68% of your data will fall within one standard deviation. If you go two standard deviations, okay, and I'll show you what I mean by this in just a minute. That means that 95% of your data fall within two standard deviations. And if you have three standard deviations, that means that 99.7% of your data fall within three standard deviations, okay? So how do I use something like this? Well, let's say that I gave you some data and I tell you that the mean of your data is 50, okay? And then I tell you your standard deviation is 5. All right, how would I determine where 68% of your data fall? Well, we draw our bell-shaped curve, normal distribution, and I put my mean in the middle, and then I go 5 to the right and 5 to the left, which means I'm going to add 5, so this will be 55. I'm going to take away 5, so this will be 45. So what this means, this is one standard deviation. One standard deviation would be between 45 and 55. That means that 68% of your data will fall between 45 and 55. Okay, if I go two standard deviations, I would add 5 more, which is 60, and I would take away 5 more, which is 40. That means that between 40 and 60, that's 2 standard deviations. So this is 1 standard deviation. This is 2 standard deviations. 95% of our data would fall between 40 and 60. Okay, and then if I wanted to go 3 standard deviations, I would go 5 more this way and 5 more this way. Okay, so that means that 99.7% of your data will fall between 35 and 65. Okay. All right, so this is kind of how empirical rule works, and there should be plenty of videos on My Open Math that pertains to the empirical rule, but I just kind of wanted to show you how you get that, okay? Now, let's say that your data is not 1 standard deviation or 2 standard deviation or 3 standard deviations, okay? It falls maybe somewhere in the middle, maybe 1.5 or 2.5 or negative 1.5 or negative 1.3. Then you're going to use your z-scores. To find the z-score, there is a formula that your book and your notes give you, and it's your data value minus your mean, all divided by your standard deviation. So let's say I gave you the data value would be, let's just say it's 65, and we'll use the same mean, the same standard deviation. No, that's not going to work. Let's do a different number. One that's not so nice. Let's say 67. Let's say your data value is 67. We know our mean is 50 and our standard deviation is 5. Okay. So when we do that, we plug it into our formula. So 67 minus 50 divided by 5. And we can plug that in the calculator. 67 minus 50, we know is 17. And 17 divided by 5 is 3.4, which is going to be over what we normally do. Man, I'm just not making up a good number here. Let's try another number. We don't usually do anything over 3. So I'm not going to give you one that's going to be over 3. All right, let's say 63. Let's try that one. All right, 63 minus 50 is 13 divided by 5. It's going to be 2.6. So 63 minus 50 all divided by 5, 13 divided by 5 is going to be 2.6. All right, so how we use our chart is I've attached the z-score chart. Open this back up for you. All right, so here's what it looks like. So I would go to 2.6, and the percentage here is 0.4953. So you can see that when we draw this z-score, you're going from 0 to 2.6 here, and that means that percentage here is going to be, what was it, 2.6, 0.4953. 0.4953. Okay. So that means that it falls out. Now, if I was looking at a negative 2.6, okay, that's the same distance. Remember, this is symmetric. Then this would also be 0.4953. So for the negative z-scores, you're going to look up the same thing. Okay. Now, what I want to show you guys is how do we find z-scores between something. Let's say that I want to find the z-score of, I'm going to give you some. Let's find 1.32. I want to find between negative 1.4 and 1.5. I want to find the z-score of negative 1.43. And then I want to find between 2.1 and 1.5. And then also between negative 1.4 and negative 1.2. All right, so if we're finding the z-score of 1.32, what that means, I'm going to draw my bell-shaped curve. There's 0 and then 1.32. I just want to find our regular old z-score from 0 to 1.32. So I go to my chart and I'm looking up 1.32. And that's going to be this one right here. You see it 1.3 and then 0.02. It's going to be 0.4066. So this represents 0.4066. So if I wanted the percent of that, how do we change a decimal to a percent? We go 2 places to the right. So this would be 40.66%. Okay, your data will fall, about 40.66% of your data will fall between that. Okay. All right, now I want to do between negative 1.4 and 1.5. So between negative 1.4 and 1.5. So how would I do that? Okay, well, you're going to have to find the z-score, the percentages between both of these. And I know that the negative is the same thing as the positive, right? So I have to look up the 1.5, which we can see is 0.4322. Look at that again, 0.4332. And then I look up 1.4 because, again, the negative is the same as the positive, and that's going to be 0.4192. Okay? But I want between these two. So if I want between these two, then I want both of these. So what you're going to do with these is you're going to add them together, 0.4332 plus 0.4192. We're going to add these together. So when they have different signs on these z-scores, you're going to add. So different sign, add. All right. That's going to be a 4, 9, 10, 11, 12. Carry the 1, 4, 5, 6, 3, 4, 5, sorry, and then 8. So my final answer here would be 85.24%. Okay. If I'm looking up a C-score at negative 1.43, again, you're going to look up positive 1.43, which is going to be right here, 0.4236. It's 0.4326, which is a 43.26%. Okay, again, for the negative, you just look at the positive. All right, for this one, I'm going to draw this one. We want to look at between 1.5 and 2.1. So the problem is here, we have one that's here, that's the 1.5, and then we have the 2.1, okay? And we want between that. So what you're going to have to do is you're going to have to look up the 2.1, and you're going to have to look up the 1.5, and we want what's left over. So what you're going to end up doing is you're going to have to subtract these two values. So let's look up the 2.1. 2.1 is 0.4821. 0.4821. And then the 1.5 is 0.4332. 1.5 is 0.4332. Okay. And so you want what's between these two, so you're going to have to subtract these two numbers. So 4821 minus 0.4332. Okay. And so what that shows you is if you have the same sign, then you're going to add those. If you have different sign you add, same sign you subtract. So 0.4821 minus 0.4332. And you'll end up with 0.0489. So your percentage here is 4.89%. Okay, same sign, subtract. All right, same sign here, so we're going to subtract these two. So I'm going to draw at 0. Here's negative 1.4, negative 1.2. We're going to look up both of these. We want what's in between it. Negative 1.2, 1.2 is 0.3849, 3849. And 1.4 is 0.4192. All right, so we're going to subtract 0.4192 minus 0.3849. And we get 0.0343. So that's 3.43%. Okay, so I just wanted to kind of go over a few of those with you guys. If you have any other questions, please feel free to contact me. Again, don't wait until the last day to do this. And that is